All right. Welcome, guys. Welcome to Applying the Correct Amount of Pesticide, Turf Talk Tuesday. It's actually weird doing one of these and actually seeing daylight still shining in the windows. So that time change, man, just threw me off. Holy cow. So, but I love it. I love this time of year. It's hot to trot. We spread a bunch of fertilizer yesterday, so it was good. I was actually behind a fertilizer spreader. That's I actually got to go out and hang with the crews. So that was a good day. So anyway, welcome to the class. We are going to discuss applying the correct amount of pesticides. So can everybody see the PowerPoint? Am I sharing it correctly?
Yeah.
Okay,
yes.
Good deal. Good deal. Awesome. And just trying to drag this out so I can see you guys a little bit better. Oh, there we go. Perfect. It's a cool deal. All right. So applying the correct amount of pesticide is a big thing. Calibration is key. We got to calibrate that equipment every single day we head out to the job sites. Even the textbooks that we use at the college and what you guys use to get your pesticide credits in our core manual, it said we need to calibrate our equipment from site to site. So I don't think that means from yard to yard, because that's just going to be a little bit impossible. In fact, it would drive me crazy if I was to pull into a neighborhood and actually see one of our crews actually calibrating a piece of equipment on someone's property. So that means they'd have to sweep it up and do all that nasty stuff. So I don't want that to happen. But before we get started, what is the number one reason we have a pesticide failure?
Too much chemical.
Too much chemical is bad. That is bad. But why would we actually have a pesticide failure? What is the number one reason that these applicators are out there, or green industry pros?
Not enough.
Not enough. That can be a problem.
Wrong product.
Yep.
Wrong product, of course, wrong product. But why do we choose the wrong product half the time?
Not knowing our species.
Exactly. Incorrectly identifying the pest. We don't know what it is that we're trying to kill. And that's a bad thing. So we have got to be on top of our insects, of our weeds, of our disease. We got to study this stuff. And I myself, I'm one to forget. I have to pull out the old core manual and the O&T manual and study through this stuff. And I enjoy reading that. That's good material to actually read. And it's kind of fun for me. And just like pesticide math is fun for me. So yes, I am a nerd, but I do love this side of the business. It's technical. It is very technical. And that's what makes, that's why we got to have a license. We got to be able to do this stuff. So if we're not knowing the pest we're targeting, and then I heard you guys talk about, it's a mistake to apply too much. It's a mistake to apply too little. Yes, it is. Which do you think is worse? Applying too much or too little? Or let me ask it, which do you think is going to hurt the checkbook a little bit harder if we're applying too less or too little?
Too much.
Too much?
Yeah.
Too little.
Too little. I like that. Why is too little?
Because then you got to go back and retreat.
You got to go back and retreat. So you don't kill the target pest. The customer's calling you, complaining, they're upset, wishing you had done a better job. So you're having to go back and you're having to redo it. So you're having to make another application. And if it's not you, if you're sending that technician back out there, they're upset that they're having to go back to the same yard. So they're going to probably dump a little bit more in there. So you're actually getting way more on that second application. And if you read the label, and label's the law, they're actually applying way more than needed. We can't go back and just figure out that little bit that we should have added and spray that again. No, we're having to make a complete application. And so we've got to calibrate these equipments, our push spreaders, our backpack sprayers, our boom sprayers, our hose that we're pulling off the truck. These pieces of equipment have to be calibrated all the time. All right. And so to use pesticides successfully, you must apply the correct amount over the target area in a uniform way. Errors in rate or uniformity may waste money, injure the plants. We definitely don't want to do that. They're going to damage the environment. Remember, we're stewards of the land. We're supposed to protect the environment. We can fail to control the pest, and we will result in fines for illegal application. So we may have an inspector show up, start asking us questions. If we don't know, we don't act like we know what we're talking about and being able to state the correct amount that we're using, they might get a little upset and start investigating more and realize we do not know what we are doing. And so you should know rather than guess whether you are applying the correct amount of pesticide. And so a lot of it begins with actually knowing the size of the areas that we're going to be spraying. We got to know the square footage. How many of you guys know exactly how many square feet of turf you treat in an application round? We got all kinds of cool software programs out there to kind of help us keep up with that. Or some of us still might be a little old school and writing it in an Excel sheet or in a notebook. But we really need to know how many square feet of turf we're treating each round. So we need to measure each property individually, whether we're using, one of your geodata base, those are pretty accurate, to be honest with you. I've double checked it. You can get pretty darn close by measuring it on your local municipality's geodata site, or you got to go out there and manually measure it with a measuring wheel. We're going to measure our small sites in square feet, the larger sites in acres. So when you are dealing with these large acre sites, your mistakes are going to be very, very costly. And then we do need to subtract the areas not treated, meaning shrub beds, your sidewalks, your tree rings, your driveways, and any other areas that are not on the property. Because you can go to the tax map and figure out that it's, a third of an acre or a fourth of an acre, but then you got to subtract out all the hardscapes, the house itself, the floor plan, and get the total number of square feet of turf that you're going to treat. You need to know that. And that at the end of the year, you know how much you've treated. You start getting some of these discounts by, Site One, your other vendors. They may give a little discount if you start going ahead and buying some product for the next year. You may be able to go ahead and do that. But you got to know the sizes that you're treating. And so here's a basic geometry that we would use in calculating our square footage. We got the circle. That's pi r squared. So pi is a constant, 3.14. Radius is, half the circle. It's half the diameter. You got a rectangle, length times width. I wish all properties were like that, but they're not. Impossible, ain't it? Just the way these developers cut them up. Then we got a triangle. That's base times the height divided by 2. And then you got a trapezoid. We're taking A plus the B, dividing it by 2, and multiplying it by the height. And so here's a typical golf course site. If we got any golf course people on here, I know this is a review, but this is actually kind of cool, figuring out how much square footage is actually in let's call it hole number 1. And so we got A, which is a circle. We've got B, it's a rectangle. C is a triangle. D, we got that trapezoid. So A, 3.14, that's our constant, times 70 times 70, because our radius is 70 feet right here. And so we got 15,386 square feet in that. Then B is 170 square feet times the 90. So we got 15,300 square feet. And then we got our triangle. We got a 50 feet here of our height. So 90 times the 50 divided by 2. And it gives us 2,250 square feet. And then our trapezoid, the 115 plus the 140 divided by 2 times the 40 foot of height gives us 5,100 square feet. So we've got, almost an acre, lacking 5,000 some square feet in this one golf course hole. So those are some weird shapes, but we need to be able to do that. Anybody ever use one of those handheld measuring devices or the measuring wheels that connects to your cell phone and you kind of trace around it, like Cart Plus or Carta or whatever? I keep seeing them on Instagram and stuff. They look real cool. whether or not they work that good, they might. I don't know, but still, nothing like getting out there and measuring it with a good old tape measure or mechanical measuring wheel. And so calibration, the process of measuring output and adjusting your equipment to apply the right amount of pesticide to the target area. It needs to be completed by the individual making applications. Why is that?
Walking speed.
Walking speed, exactly. You might have an employee that might be 6'5", and then you might have another employee that could be, 5'2". They do not need to calibrate each other's equipment. The taller individual is going to be walking a lot faster. Shorter individual, even though he might be humping it out there, it's still not going to be the same. So the individual running the equipment needs to calibrate it. Properly calibrated equipment will deliver the right amount and will apply it uniformly. And so if we calibrate it in the mornings, do you think there might be any other time during the day that we may need to calibrate that piece of equipment?
After lunch.
At lunch. Yeah. And why is that?
You're tired.
You're tireder, your belly's full, the temperature's rising, but it's going to be tough to do that. Like I said, I don't want our guys out on job sites doing it. I'd much rather them come back and do it, or just apply chemicals in the morning and do something else in the afternoon, because I guarantee you when they slow down, what's happening to that application rate?
You're over applying.
You're over applying it, and you could be almost doubling it at times. And so they need that equipment recalibrated. They're tired, they're hot, belly's full, they're slowing down. And then if they change chemical, they would definitely need to recalibrate the equipment. If they're spraying something in the morning and going back and spraying something different in the afternoon, got to calibrate it again. The label will tell you the application rate. We're going to see it either like 4 ounces per gallon or 4 ounces per 1,000 square feet. I love that. 3 ounces per gallon, product per volume. That's like if we're mixing up some Roundup, we're doing some spot spraying or whatever. Or we may see a 2% solution, and this is the percent solution mixed with our water. And so when to calibrate, before using it the first time each year, changing the type of pesticide, changing the rate and speed at which it's applied. Now think about this. What if we're in the morning time in a neighborhood where most of the yards are kind of flat, and then we move to a neighborhood across town and we're applying fertilizer, spraying, and some of the lots are hilly? That's going to be a definite change in our speed. Hilly yards, we're not going to be pushing as fast. You might want to recalibrate. And then here, this is what throws me off a little bit and comes from our core manual. When equipment is moved from one site to another, especially important with rotary spreaders because their settings are easily knocked out of place. Why does that happen? Why does our push spreaders get knocked out of calibration?
Bouncing around
In the back of that truck.
Yep.
They need to be secured. They are the first ones to lose that calibration. And I love the push spreader. All right. So with calibration, depends on your equipment choice, your speed. Normal people are going to walk around, between 2 miles per hour. If we're riding like one of the ride-on sprayers or whatever, we're going to be going around 4 to 6 miles an hour. And so again, we talked about that lunchtime. We may be walking at 3 miles an hour, before lunch. We eat that lunch, it gets hotter. We may slow down to 2 miles an hour. That's going to dump more pesticide out on the yard. It's costing you money. It's illegal because you're not supposed to apply more than the label rate. And you just don't want to do that. You want to be that environmentalist. You want to be the good person when it comes to applying these chemicals. We get enough bad publicity being lawn care companies. People, for some reason, they think that we dump pesticides all down the drains and everything else. We don't need to give them any other reasons to criticize us. Backpacks, that in a push spreader, you're in business. I mean, you really are. And it's 2 of my favorite pieces of equipment. I know we got the fancy ride-on and the hose sprayer to pull off the truck, but with these 2 pieces of equipment, you can go to town. And this backpack, it's going to have compressed air up to 30 PSI. The pressure drops as the solution is sprayed. So you got to continuously, pump it up. You want to have a gauge that's on the wand, and you want to keep it within 10 PSI of the initial pressure. I know a lot of guys and gals are using the battery operated backpacks. Is anybody using any of those? It keeps that constant pressure, or keeps it coming out.
Yeah,
Who said yeah?
Jason.
Jason, hey, how are you finding those? Or how's the batteries holding up? Are they good or?
So far we've done okay. I mean, we've tried the Ryobis. I'm
Okay.
on the Milwaukee right now. So far so good.
Good deal. Good deal. How many tanks can you spray on a battery? Do you know offhand?
I think we're averaging anywhere from 4 to 5. Just kind of depends.
Yeah.
The problem I run into is being at the beach, so we got to be careful because of the wind, and so that's why we went to the batteries.
Gotcha. Yeah, everything is constant without. So cool. Good deal. What beach are y'all at?
Wrightsville.
Okay. So calibrating it for your backpack. If you're applying pesticide to an area measured in square feet, calibrate the sprayer by staking out 1,000 square foot test plot. For example, a 20 by 50 on a surface similar to the treatment site. Now, you're not going to, probably calibrate on grass because you're not going to be able to see it. You're going to do it on asphalt. What this is meaning is it needs to be on a similar level. So if you're on a hill, you need to find a hilly spot. If you're on a flat ground, find a piece of flat ground. And you're going to mark it out 20 by 50. And then you're going to fill your sprayer half full with water, no pesticide. The only time when we do calibrate with the pesticide is if we're using a granular spreader. We have to calibrate with the pesticide that we're using. But here in the backpack, we're just going to use water. We're going to maintain the pumping pressure that you will use during the application. Remember, keep it within 10 PSI. Record the number of seconds it takes to spray the test plot evenly while walking at a comfortable, steady pace. It's a good idea to spray the test plot 2 or 3 times and figure the average time. Use the average in your calibration. So spray it the 3 times, take your average. Then step 2, you're going to stand still and you're going to spray into a container for the average time found in step 1. The number of ounces collected equals the amount of spray delivered to 1,000 square feet. And when this number, you can calculate the amount of pesticide and water needed to treat the target area. And so we're going to look at our first problem. And here we're going to apply a herbicide to a lawn that's 40 by 65 feet, 2,600 square foot lawn. I would love to have a ton of those. But your label application rate is 2 ounces of herbicide are to be mixed with a sufficient amount of water to treat 1,000 square feet. This can be expressed as 2 ounces per 1,000. And I love breaking down our properties into 1,000 square foot blocks. So if we've got a 20,000 square foot block, I've got 20 blocks inside of it. The area to be treated is the 40 by 65, 2,600. Test plot to cover 1,000 square foot is 80 seconds. The amount of water collected in 80 seconds is 57 ounces. And so our sprayer output is 57 ounces per 1,000 square feet. So we're going to determine the total spray mixture needed. Now that's different than the amount of water and pesticide needed. The total spray mixture is both your pesticide and your water. So you're going to multiply the target area by the sprayer output, 2,600 square feet times 57 ounces per 1,000. Excuse me. That gives us 148,200 ounces. And we divide that by 1,000. We've got 148.2 ounces. We're going to round off to 148. So basically, our total spray mixture is 148. That's pesticide and water. So next, we got to determine the amount of herbicide we need. So we multiply the target area by the labeled application rate, 2,600 square feet times 2 ounces per 1,000 gives us 5,200. Divide by the 1,000 square feet. So we need 5.2 ounces of herbicide. And so we need to mix a little more than 5 ounces of herbicide to be added to 143 ounces of water. Why only 143 ounces of water?
Total
the rest is chemical.
Yeah, the rest is chemical. So our total spray mixture is the 148. And so we've got to subtract our pesticide from the total spray mixture, and the rest of it is water. So 143 ounces of water and a little more than 5 ounces of herbicide, and that will get us our total spray mixture to treat the 40 by 65 square foot lawn. And so basically we're going to have just a 1.1 gallon of water because there's 128 ounces in a gallon. All right, so calibrating by volume. This is when we are going to spray to wet or paint the plant. So we're going to kind of just drench it and actually get it wet. We're going to add water, no pesticide, to the tank and pressurize it, then record the number of seconds it takes to spray a representative plant thoroughly. So let's say we got a bed of azaleas or whatever. We're going to find one that represents all the plants, and we're going to spray to wet it. We're going to time it. Then we're going to spray the water into a container for that length of time, and then we'll use this number to calculate the amount of water and product needed. And so here is those azaleas. We've got 18 azaleas in a plant bed, and we're going to apply an insecticide. Your labeled rate is 3 ounces of insecticide per gallon of water. Comes directly from your label. So the number of plants to treat is 18. The seconds to spray one average plant is 12. The amount of water collected in 12 ounces or 12 seconds is 10 ounces. So determine that total spray mixture needed, multiply the total number of plants to treat by the amount of water collected to treat one plant. So 18 times the 10 ounces, we have 180 ounces. We convert ounces to gallons, so we divide it by 128, and we have 1.4 gallons of water needed, or total spray mixture, my fault. To determine the amount of insecticide needed, multiply the labeled rate by the total spray mixture. 3 ounces per gallon times 1.4 is 4.2 ounces. So add a little more than 4 ounces of insecticide to 176 ounces of water. Remember, subtract out the pesticide from the water, and that'll give us 176 ounces of water. And then 4 ounces of chemical to treat the 18 azaleas. For spot treatments and percent solutions, calibration is usually not necessary in spot treatments. If we're going to mix a little Roundup and go around and spot spray some weeds and shrub beds, we should be fine. The label will state either 6 teaspoons per gallon of water to be sprayed wet, or it'll say, 3 ounces or 2 ounces per gallon of water. But here, let's look at mixing 3 gallons of a 2% pesticide solution in water. So we want to convert that 2% to decimal. It's 0.02. Just divide it by 100. So 0.02. Determine the number of ounces of pesticide needed per gallon. We're going to multiply the rate per gallon, which is 0.02, by 128 ounces, and that gives us 2.6 ounces. To determine the amount of pesticide needed, multiply the amount of pesticide per gallon by your total spray mixture. 2.6 per gallon times 3 gallons gives us 7.8 ounces. So mix a little less than 8 ounces of pesticide with slightly less than 3 gallons of water. 2% solution. Not much that, I don't know. I don't run into a lot of these percent solutions. Anybody calibrating for that or spraying a particular pesticide that you need for that? We just don't do much with it. Nozzle knowledge. Yeah, here's just your parts. You've got your nozzle body. There's the diaphragm, the strainer, the tip, and the cap. You got to clean these things out. They need to be cleaned out so pretty much often, maybe once a week. Some people probably do it every single day. But they pull them off, wash them with soap and water, put them back in. Some common nozzle types. You've got solid cone, standard flat, or even a hollow cone. And then figure there to spray uniformly with a flat fan nozzle, adjust so that 30 to 50% of the spray pattern overlaps. Now, when you are calibrating your equipment, you would want to get your technicians trained. The first thing they shouldn't do is go out and calibrate the equipment. You got to make sure that they know what they are doing when it comes to this. So they're going to need a little bit of training because they're going to be turned loose. Lawn care is one of the loneliest businesses out there. I mean, it's one person in the truck. You're driving around to multiple yards. You may not see anybody because some of your customers probably ain't going to be home. It can get very lonely, and they're not going to have somebody to tag along with and actually get trained up on it. So you want to make sure they know what they're doing before they go out. And with your spray guns, so to calibrate this, you would divide 1,000 square feet by your swath width to determine the distance to the test of the test course. So we're going to spray this test course with water using the technique you will use for your application. Begin spraying just before you enter the course. That way you're covering the entire course. Record the number of seconds from step 3, measure and convert to gallons. The amount collected is equivalent to the spray gun output per 1,000 square feet. And for acres, you would just multiply by 43.56. And so calibration of the spray gun for a swath width of 5 feet, meaning that's what you're spraying 2.5 feet on either side of you. You're going to mark a test course that is 200 feet long. So 1,000 square feet divided by 5 feet is 200 feet. Average time in seconds to spray the 200-foot test course. Did it one time in 77 seconds, another time in 79, and another in 78. So the average of that is 78 seconds. Gallons sprayed into a bucket in 78 seconds is 5.25. So your output is equivalent to 5.25 gallons per 1,000 square feet, or 228.7 gallons per acre if we multiplied it by the 43.56. And note your calibration, if your calibration is not within 5% of the label rate, adjust your walking speed, either the nozzle or the pressure, and then recalibrate until your output comes within 5% of the label rate. So a ton of spray guns going out there. Every day you go out, you're going to see the lawn care companies hot to trot this time of year. Boom sprayers. If we've got a, tractor mount sprayer, or if using a boom sprayer like on one of your mowers or whatever, this is how you're going to calibrate these guys. Your hydraulic sprayers produce pressures up to 500 PSI. The application rates can vary widely. Some materials are applied at a rate of 1 quart per 1,000 square feet, and others may be applied at 100 gallons or more per acre. The height of the nozzle above the ground determines the swath width or the effective sprayed area per nozzle, and the height is usually 14 to 18 inches above the target surface. And so your nozzle spacing, you do want that overlap right here. And the pressures may be increased 4 times to double your sprayer output, and adjust pressure only to make the small changes in output. And so you can really dump more pesticides out on a yard not needed if these things aren't calibrated correctly. So you're going to do a pre-calibration check. You're going to do a spray pattern. You're going to check all components clean and the correct type. So like I said, you definitely want some clean nozzles. You'll clean them and the screens with soapy water and a soft brush. Rinse the spray tank and partially fill with clean water. And a lot of the times when we finish for the day, we don't clean our equipment. And each technician, when they get into the shop, they need to clean it. They need to rinse it out. They need to get it ready to go the next day. And you definitely don't need to leave these sprayers out on some cool nights. Like I think we're going to get down close to freezing here in the next night or two. I believe that's what I saw. And if that happens and you've been out spraying and you got a little bit of water or whatever, that can freeze and bust inside the tank. It can, crack, freeze and crack the diaphragms. You want to keep them inside if at all possible. But pressurize your sprayer and then flush your hoses and the boom, reattach the nozzle tips, and then spray water on a paved surface. So that's what we're doing in our pre-calibration checklist. We want 50% overlap. It's an overhead view. And here we can see streaks in the pattern showing problems with either nozzle height, alignment, or the output. So you got some nozzles here that are really putting out some pesticides way too much. And it looks like you got some in here that's doing pretty good. All right. So with a container in ounces, catch the output from each nozzle for 20 seconds. So you'd want to, you know, mount one underneath it, or you need to get some help to actually do this. You're going to add the amounts and divide by the number of nozzles for average output. If the output is 10% above or below the average, replace the nozzle. You'll repeat step 1, use new results for the new average in steps 2 and 3. And so we're going to look at a little test here. We got 2 output tests, and it looks like we've got an 8 nozzle sprayer. And so we sprayed them in there for 20 seconds. The average is 15.4. So we've got 16 coming out of nozzle 1, 12 out of number 2, 3 is 15, 4 is 16, 5, 16, 6, 15, 7 is 14, and 8 is 19. So you can tell, you know, from 12 to 19, that's a big difference. But we're going to average these. All of these added up to 123. So we divide by 8. The acceptable range is 13.9 to 16.9. So basically what we're doing, we're taking 10% of the average and subtracting it and adding it. And so, you know, 10% of 15.4 is the 1.4. We're plus or minus in it. And so that's going to give us the acceptable range of 13.9 to 16.9. So automatically 12 is out, and then 19 is out. So nozzle 2 and 8 should be cleaned and or replaced, just depending on what's wrong with it. And so you go back and you do this test again, and you've got 15, 16, 15, 16. That all looks good. 16, 15, 15, 17. That, you know, getting a little close, because our average, add them all up, we've got 125 divide by 8. That is an average of 15.6. The acceptable range is 14 to 17.2. With our average being 15.6, 10% is the 1.56. And so all of the nozzles are now within the acceptable range. All right. So now we're going to mark a 200-foot course on a site that is typical of the surface and soil conditions of the area to be sprayed. We're going to fill the tank half full, test which gear and RPM will allow the sprayer to maintain pressure on nozzles between a constant 3 to 5 miles per hour. We're going to drive the sprayer on a 200-foot course 3 times. We're going to take that average, and we're going to start far enough away to reach the speed before the first marker. We want to be going the speed that we're going to be spraying the application. And so measuring our ground speed, our test course length was 200 feet. Our test run in times was 31.5, 30.3, and 29.2. We're going to average these, add them up, divide by 3. So our average is the 30.3 seconds. So our miles per hour is 200 feet times 60, the constant, divided by the 30.3 seconds times 88 gives us 4.5 miles per hour. So that's what we're going to be driving our piece of equipment. And so collect the output, collect for 1 minute or 30 seconds times 2, divide the number of ounces per minute, OPMs, by 128 to find the gallons per minute, measure the distance in inches between the tips of the adjacent nozzles. This is your swath width, and then determine sprayer output in gallons per acre by inserting the values from steps 2 and 3 and the miles per hour from your test course in the following formula. And so here it is. We got our gallons per acre, which is gallons per minute, times the 5,940, times the miles per hour, times your W or your swath width. If output is specified in gallons per thousand on the label, divide the gallons per acre by 43.56. So here we got a problem. We're going to mix pesticide with water to treat 2.5 acres with a boom sprayer. You already know our label rate. We've read the label. It says that it's going to be 5 pints per acre in a spray volume of 30 gallons per acre. We know our miles per hour to be 4.5. Our nozzle spacing is W, 20 inches, and our average nozzle output is 56 ounces per minute, or 0.44 gallons per minute. That's 56 divided by the 128. So to determine sprayer output in gallons per acres, the 0.44 times the 5940 times the 4.5 miles per hour times our nozzle spacing of 20 equals the 29. 2,613.6 divided by 90. This output is within 5% of the label GPA, gallons per acre. So what is the 10%? The 30 plus 1.5. So no adjustment is needed. Plus or minus the 150. We are in it with 29. So we're good to go. To determine the total spray mixture needed, we're going to multiply the target area by the sprayer output. 2.5 acres times 29 gallons per acre is 72.5 gallons. Determine the amount of pesticide needed. We're going to multiply the target area by the labeled rate. 2.5 acres times 5 pint per acre equals 12.5 pints. And so to treat 2.5 acres, add 12.5 pints of pesticide to 70.9 gallons of water. Remember, we got to minus out the pints of pesticide from the 72.5 gallons of total spray mixture. And so making adjustments, if your sprayer's output is not within the 5% of the gallons per acre on the label recommendation, then adjust the pressure, speed, or nozzles according to the guidelines in table 10.2. And here is table 10.2 right out of the core manual. If measured output is 5 to 10% of the label GPA, then increase your pressure to deliver more spray or decrease pressure to deliver less spray. If the measured output varies from the label gallons per acre by 10 to 25%, then adjust travel speed. Slower speeds will deliver more spray. Faster speeds deliver less spray. Measure speed under field conditions, and now use new speed in figuring your gallons per acre. If measured output varies from label gallons per acre by more than 25%, then change the nozzles and repeat the pre-calibration check and calibration process. Granular spreaders, the good stuff. Establish your swath width, determine your application rate, and then we're going to look at drop or rotary spreaders. I don't know too many people that are using drop spreaders anymore. I wouldn't, but I do love the rotary spreader. So method one, we've got a catch pan. You need to measure a course 100 square feet. You need to fill the hopper half full. Again, remember, we're having to use the fertilizer or the pesticide that we are using to calibrate this piece of equipment. Push the spreader over the test course and weigh the material in the pan. Not my favorite way to do it, but it does work. You can determine the application rate in pounds per 1,000 square feet, and then multiply the weight by 10. Compare the spreader application rate to the label rate. With the calibrate the drop spreader, method 2, the sweep and weigh. Method 3, weigh before and after, but not too many people, like I said, use it. Here, using the catch pan method, you got a label rate of 2 pounds of product per 1,000 square feet. Your spreader swath width is 3 feet. So that means your test course is going to be 33 feet. Amount collected in the catch pan is 120 grams or 0.26 pounds. And then your spreader rate per 1,000 is 0.26 times the 10 or 2.6 pounds. Adjust the spreader by reducing the gate opening until it falls between 1.8 and 2.2 pounds. The 2 pounds plus or minus the 10%. Calibrate the drop spreader with the weigh before and after method. Put 2 pounds of granulars in a drop spreader that has a swath width of 2 feet. After applying the product to a 50-foot test course, you recover 1.75 pounds of granulars from the spreader. The calibrated rate is 0.25 pounds per 1,000 square feet or 2.5 per 1,000 square feet. And there's just going back and forth. Create the header strips on the ends. Calibrating the rotary spreader. This is one of my favorite ways to do this. You're going to put a box in the middle. You're going to create a test course, and you're going to have boxes along the side. I think it takes about 9 to do it, if I'm not mistaken. But you're going to put one box in the middle, and then you're going to space boxes on either side at 2-foot intervals. You're going to make 3 passes. You're going to go over these boxes. So you're going to go over it with the spreader on, come back around and go over it again, and then go over it a 3rd time. So make 3 passes in the same direction. You're going to record the weight, or better yet, pour them into jars marked with the box number. The center jar should have the most product with the amounts tapering off evenly. So it's gonna go like this. The jar in the middle is going to have the most. You want to find the jars on both sides that have half the product of what's in the middle. And so here you can see the young man driving over these boxes. He's going to do it 3 times. And then he's got the jars here. So number 6. So we got 1, 7, 8, 9, 10, 11. So they're actually doing 11. The jar in the middle is 6. And so we're going to find out where half the amount is in there. You can see it a little bit better in this picture right here. We've got the 9 jars. We got the number 5 is right in the middle. So whatever half this weight is, looks like it's number 2. And number 8, remember, these are on 2-foot intervals. So 2, 4, 6, 8, 10, 12. We got a swath width of 12 feet. Now, if we know our swath width of the spreader, we can jump into our core manual, and table 10.3 gives us the distance and effective swath width for rotary spreaders equal to 1,000. So what was our swath width? 12 feet. So we know our test course is going to be 84 feet. And so to calibrate the rotary spreader, you're going to have a label rate of 80 pounds per acre. But remember, we're spreading it using 2 passes over the treatment site. So we got a label rate of 80 pounds per acre. The effective swath width is 12 feet. So we know our calibration course is going to be 84 feet. So the beginning weight of the product, 908 grams, 2 pounds. End weight of the product, 426. The difference, 482 or 1.06 pounds. The 482 divided by 454. The spreader is calibrated to apply 1.06 pounds per 1,000 square feet. So your rate per acre is equivalent to the rate per 1,000 square feet times 43.56, or 1.06 times 43.56. So we're putting out 46.2 pounds per acre. This rate is higher than the rate needed of 40 pounds per acre, 1/2 of 80. So we need to adjust the spreader by reducing the gate opening until the rate falls within 10% of 40 pounds, between 36 and 44. So they got the 10% of the 40 pounds per acre. So minus it would be 36. Adding it to it is 44 pounds. So to determine the amount of granular insecticide needed to treat 2.5 acres, with our label rate of 3 pounds per 1,000, convert acres to square feet. 2.5 acres times 43,560 is 108,900 square feet. To get the total amount of product needed, you multiply the area by the application rate. 108,900 square feet times 3 pounds per 1,000 gives us 326,700 pounds, divided by 1,000, or 326.7 pounds. So we're going to need what? 7.5 bags to treat the 2.5 acres. And so when you're driving over the site, you can use the right angle method, make 2 passes that do 90 degrees from each, or you can do the half width method, applying parallel passes 1/2 the effective swath width. I like doing this because it just feels better going over the property once, and that's kind of how we do it. And so that kind of wraps up the slide deck. So we got any questions, comments, or concerns? Is there anybody on here that I did not get your pesticide license? I think, let's see.
Could be mine, Eric.
Hey, Mr. Morris.
How you doing today?
Good. Hope you are, sir.
Yeah.
What's your license, sir?
026 1266
12660.
Yep.
Good deal. Good deal. And did Mr. Flowers jump in? I don't see him on the panelist list here. And Matthew Tuttle. All right. So no, that was it. All right. Any questions? Got about 4 minutes.
Eric, just a short one on next week. Do you have a class scheduled yet for next week?
Yes. I forget the title, but yeah, I've got them scheduled out. Well, the Department of Ag's approved them for all Tuesdays, but I've got March and April on the website.
Okay, thank you.
You're welcome. Anybody want copies of the slide deck or?
Please, I'd like to have that. It's
Okay.
Kathy.
All right. I'll grab everybody's email off of the Zoom meeting. Once the meeting shuts down, I get a email response of everybody that was in it, and then the number of minutes that y'all were in it. So I'll pull those emails and attach the slide. I'll get these uploaded here in a little bit, and you should see them on your license in 2 or 3 days. So.
Thank you, sir.
Thursday night, we still got the contractors licenses.
I'm sorry, who was talking? I didn't.
Jared,
Hey, Jared. Yeah, I'm doing them every Thursday for contractors. Have you signed up for yet?
I have not. I
Okay.
haven't had a chance to.
Got you. I'd ran into some family stuff. So this Thursday may not happen, but I've got them scheduled every Thursday night up until July 31st. So if I did have to reschedule that one, just touch base with me tomorrow, and I'll
Okay.
let you know if we're still going to do the one this Thursday. I hate having to cancel, but unfortunately we've got to get some stuff for the family.
Are you going to offer just a full day class online for it?
Yeah, I'm doing an all day, 7-hour Con Ed for the landscape contractors. It's I think it's July 24th.
I'll get an email confirming that, correct?
Yes. And this one is Jared, what's your landscape contractor's license? You got that by hand? And is anybody else on here landscape
Yes.
contractor?
Hold on a second, Eric. I got one.
It's
This morning.
3126.
3. That's Jared, right? 3
Yes,
1
sir.
3126. And that's your personal, right?
Yes.
And then Marty, you got one?
2951.
2951. Okay. All right.
Hey, Eric, do you do a combination sometimes
Yes.
with irrigation and
I do on the all day course. You get 7 contractors, 5 irrigation, and 2 pesticides. But if I'm not mistaken, this class tonight gets you 1 landscape credit.
Yes.
Yes.
Okay, cool. Yep. So I will type up your proofs of attendance and email it with you along with the slides.
Sounds good.
And so just any other landscape contractors on here? So Marty and Jared, contractors. Okay. And did somebody have a question?
No, Eric, next week's labeling and formulation.
Labeling. Okay. Is it called label calculations?
Labeling and formulations.
Label. Okay. Gotcha. Yeah. It's this one, applying the correct amount, and then another math one that gets you NCLCLB credits too. So I'll start putting those in the emails when I send them out, if it's good for 1 landscape and a pesticide credit. Because I knew if you took some of the Turf Talk Tuesdays and then I'm doing all 4 business and 1 landscape rotating on the Thursday nights. And then there's 2 pesticide credits that get you the other 2 landscape contractor ones. So it should even out. So yeah, taking the 4 business, and then there's 1 landscape that I rotate every Thursday night for the landscape contractors. And then if you were picked up, like you guys picked up this one tonight, and then there's another pesticide class that would get you the other landscape credit for the licensing board.
Hey, Eric, can you do B license in any of your trainings or not?
B, you talking about business?
Yes, sir. Public health.
Yeah,
B on your pesticide.
No, they haven't like when I submit a lecture to the Department of Ag, they'll send me an email saying been approved for, the categories. And I haven't done it. I don't know why they don't approve it for public health. And it's like weird, like some get approved for aquatics and some don't. And, but I just, go with what they say.
Yeah, sorry I was late a little bit earlier. I was already on a Zoom for another pesticide training.
No,
at the same time.
Gotcha.
How about this? Where can I get a competent person's training for OSHA?
You need like OSHA 15 or OSHA 30?
You're talking about a trench and shoring, ain't you?
No.
The trench and shoring competent person?
Yeah, I had some licenses in the past for that, but
You talking about getting like OSHA certified?
I guess I'm bidding on a job. It says competent person proof.
That'd be trenching and shoring. Neff Rental used to do some of those classes.
Yeah. We're getting set up at the college to teach the OSHA 15 and OSHA 30. And a lot of construction sites want the OSHA 30, which will give you the OSHA 15, but it's like, that is a 30-hour course. That's why they call it the 30. But we got to send somebody to get trained up to teach that portion of it. So we're trying to incorporate it in some of our safety classes that we have to teach.
Okay.
Yeah, I know. Like some of these jobs, bidding on them and stuff, they want to see all that. Man, are y'all running it? Like, how many of y'all use subcontractors? Anybody? We sub out a lot of parking lot sweeping, and it's like we got a guy to do it, and he sent me the invoice. I'm like, yeah, that's great. I'm getting ready to write you the check, but I need a certificate of insurance. They don't even have insurance. And I'm like, how in the world can you be sweeping for other companies or doing it for yourself without workers' compensation? And I'm just, y'all ever run into that? That is just one of the biggest nightmares we deal with, because we do a lot. I mean, we have a GC license too. So we do for these shopping centers and commercial properties that we're cutting grass, we'll sub out pouring a sidewalk or something that gets cracked or whatever. And half these guys don't have workers' comp, general liability, or anything. So
Eric, we started getting it up front.
Yeah, and it's they tell you they got it, and you kind of trust them, and then it's like, hey man, I need that certificate, and they send you something that's I don't know, looks a little funny, and then you call the insurance company and they're like, well, they've only got general liability, no workers' comp. I'm like, man, they got 7 or 8 employees. I know. I don't know how they're getting away with it.
3's the max.
Yeah. But still, to even work for commercial jobs and stuff, I don't know why they're not having it, how they getting away with it. So, and then he tells me, he said, man, I pay my guys under the table, so they don't know how many employees I got. And why would you even say that if you're doing it?
That's why everybody pulls a lawnmower around there behind their pickup truck.
Hey, Eric,
Yes, sir.
the guy that was asking about the OSHA stuff.
Yeah.
Check out Mid-Atlantic Safety, because we have to do them for Corning fiber optic.
Yeah.
And they do a bunch of OSHA stuff.
Okay. I'd say probably some of that's online now.
Yeah. I know MASC, they do a lot of them online. I mean, I'm fortunate because they have an office here in Wilmington.
Gotcha.
But I have to send all my guys to one just to go on a certain property in Wilmington.
Yeah. Cool
All
deal.
right, I'll look into that. I did work for a company, and that's how I got my other certifications.
Cool deal. All right. Any more questions?
Well, good.
Cool deal. Guys, I appreciate it. Thank you so much. We'll talk to you soon.
Thank
Bye.
you.
Thank you. Bye.
See you next week, Eric.
Thank you, sir. Appreciate it, guys.
Yes, sir.